Okay, so today we will discuss uh, few basic aspects related to uh, formation and manipulation or basic operations related to matrices. We will see about one-dimensional, two-dimensional, three-dimensional, and in general later on n-dimensional matrices also. Matrix formation, matrix multiplication, addition, subtraction, division, and inverse of a matrix, determinant of a matrix. These operations are very much needed if you want to develop a finite element model using Matlab. Because most of the finite element modeling in Matlab is dependent upon formation as well as assembly of different matrices, right? Whether it can be stiffness matrix, it can be a mass matrix, it can be a damping matrix. So most of the commands we have done earlier till now, command window, workspace. So these things we have done already. Look for command is there. This is similar to the help command, and control C is to terminate when the compiler becomes too busy and you want to interrupt and stop the compiler in between. And rand n is to generate random numbers, and control n is for creating a new file. Control O is for opening an existing file. Control S is for saving the file in which you are working at present. As is the case in any most of the other softwares also, control and control O and control S are used in the similar fashion. And F5 is used to run the entire program. On the other hand, F9 is used to evaluate only the set of statements or instructions which you have selected. So let us see how this F9 works. So here this is the Matlab command window, and this is a program, basic program which I have written. Okay, let me first see the effect of, show the effect of F5. So I am at present going to press F5. So the very first thing that the compiler asks me is that the present folder, this file is not found in the current directory, right? So you need to click over here, change directory, then the program will be run. So here you can see the output of the program. Complete program has been executed, all the statements have been executed and corresponding output is shown. Now suppose if I want to evaluate only part of the program, let's say I want to evaluate only this much. So for that I need not run the complete program. Sometimes the complete program may be too lengthy, it may be in thousands of lines. So if I want to execute only a few lines of the program, so for that I first select those lines, then right click, and then over here I click on selection, evaluate selection, or I can press F9. So one and the same thing, either click over here or press F9. So if I click over here, then you can see this particular statement, these three lines have been executed, and the effect of these three lines is the definition of this variable B, or you can say a matrix B. It is defined in this manner. Suppose I only want to execute only this very statement, right? So I select it and then right click, then evaluate selection. So only that particular statement has been executed. Rest of the lines of the program are not executed. Okay, that was the basic difference between F5 and F9. Then random integers can also be defined using RANDI command, and bar 3 is used to draw three-dimensional bar graphs. Title command is used to write the titles. X label is used to write the x-axis label. Then y-axis label can be written using y label. For more details, you can simply type help space and then y label, for any other command, and you can get the complete description of the command. Pause is used to pause the program for a few milliseconds, and G input is used to stop the program for, and it asks for a graphical input. Number of graphical inputs required are mentioned within the bracket sign over here. These things we had discussed earlier also. Stem 3 is basically a three-dimensional stem graph and row matrix. So let us first define a row matrix now. So here I am going to create a new program here. Let me delete this one, pressing F5. So the command window is clear now. So I first define a row matrix. So I say, let's say X is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Square bracket close, and then I press F5. Now I press F5, the same command get this, all the commands get executed, and the value of the X is also shown in the command window because I had not written a semicolon over here. If I write a semicolon over here, then press F5, the output of the program will not show the row matrix. Although the row matrix is defined as in the previous manner, you can see here in the workspace where our matrix X is there, but its value is not shown in the command window. That is the only difference. So I want to see the value also side by side. So I do not enter the semicolon here. I have deleted the semicolon, and then I press F5 and value of X is shown. Suppose I do not want a row matrix. I want to convert this X into a column vector. So I say X equal to X transpose. This is a transpose symbol. Now press F5. So you can see first a row matrix is defined as per this statement. Then as per this statement, transpose of X is taken, which becomes a column vector, and that is stored within the same variable X, and that is displayed also because there is no semicolon here, so that output is shown over here also. Okay, so we have seen these things here now: row matrix, then effect of semicolon, transpose of a matrix, and a column matrix. Now let us define a 4 by 3 matrix. So now I am going to define a 4 by 3 matrix. Let me delete this one. So I say, let's say there is a matrix A, square bracket, then I say 1, 2, 3, enter, backspace, 4, 5, 6, enter, 7, 8, 9, enter, 10, 11, 12, square bracket close, and then press F5. So this is a 4 by 3 matrix. So you can see here there are 4 rows and 3 columns, right? So over here you can see there are 4 rows. This is first row, second row, third row, and fourth row. 4 rows are there and 3 columns are there. First column, second column, and third column. 3 columns are there in this matrix. So the size of the matrix will be 4 by 3 as shown over here also in the workspace. In the workspace also it is shown. Matrix A is there in the workspace, you can see, and its size is mentioned 4 by 3. Okay, now I want to access a specific element of this matrix, right? So for that, let me erase the annotation first. Okay, now I say there is a matrix B which should be equal to only the first row of this matrix A. So how to write that? So I will say B is equal to A, round bracket, then first row means row number 1, comma, how many columns? All the columns. So all the columns are mentioned by marking a semicolon, colon over here. So now I press F5. So you can see B is equal to 1, 2, 3, which is nothing but the first row of matrix A. Suppose I want B to be, instead of this, I want B to be the last row, that is fourth row of matrix A. So how to do that? Let us see. So for that, what I do, I say B equal to A, then its fourth row and all the columns. Now press F5. So now you can see B is equal to, let me clear the previous annotations. So here B is equal to 10, 11, 12, which is nothing but the last row of matrix A. Suppose I want B to be equal to first column of this matrix A. So how to do that? So for that I say B is equal to A, then all the rows and first column only. So I press F5. So here you can see B is equal to first column only of the matrix A. And if you write over here 2, over here if instead of 1 I write 2, then press F5, then B will be equal to second column of the matrix A. If I write over here 2 is to 3, then that means start from second column, go up to third column. So now I press F5. So now you can see B is equal to this, right? Which is the last two columns of the matrix A. Clear all annotations. Suppose I want B to be containing these very elements, right? So that means B will be a sub part of A, sub matrix of A, which should contain elements lying between third row and fourth row, and second column and third column. So how to write it in a program? So we write it over here 3 is to 4. So that means third row to fourth row, then comma, and then second column to third column. Now press F5. So here you can see B is exactly the same which we want. Suppose I want B to be only containing a specific element, let's say this very element, only one element, right? So how to do that? For that we will say B is equal to, and the element, that element is basically it is fourth row and second column, right? So I will write 4 comma 2 over here. B is equal to A, then within the round bracket I write 4 comma 2, that means fourth row second column of A, and whatever element is stored there, pick it up and store it into the variable B. Now press F5. So you can see here this element value, its value is 11, element number A42, that has been now stored in the variable B. Okay, this surface graph we have discussed earlier. Surf command is used to draw surface graphs. Color bar, a side color bar can also be drawn. Comet 3 can be used to draw three-dimensional graphs also. In an animation kind of thing can be added using Comet 3. And now we will see the basic matrix operation like addition, subtraction, then matrix multiplication, division, and element by element multiplication also, and inverse of a matrix also, determinant of a matrix also. So let us see it step by step. Okay, so I define another matrix B equal to let's say it is 1 2 3, then okay, let me change the values to 10 20 30 and 40 50 60 and 70 80 90, and here I write 10 11 12. Now press F5. So simply two different matrices have been defined, you can see here. Now let us see how the matrix addition is done. So that is very simple. Write C equal to A plus B and matrix addition will be done. And the addition of the two matrices A and B, their addition output will be stored in the variable C or a matrix C. So let's press F5 here. So here you can see this is A, then B is there, then C is equal to A plus B. So all the corresponding elements are added. Like here you can see this is first row, first column 1, first row, first column 10. So 1 plus 10, that will be 11, and that is stored over here. Similarly, fourth row, third column 12, fourth row, third column 12. So 12 plus 12, that will be 24, and that is stored over here. So that is how mathematically matrix addition is done. Similarly, you can easily do matrix subtraction also. So let us, instead of writing plus sign, let's write a minus sign over here. Press F5. So this is an example of matrix subtraction. So here you can see first row, first column 1 is there, then minus first row, first column for B matrix, that is 10. So 1 minus 10. So 1 minus 10, that will be minus 9. So which is shown over here. Similarly, I am just giving one more example. Last element, fourth row, third column, 12 is there. And again over here, fourth row, third column, 12 is there. So 12 minus 12 would be 0. So which is being shown over here also. Clear annotations. Now suppose this matrix is not having the fourth row, right? The size of the matrix B has been changed to now 3 by 3. I have eliminated the fourth row. Now press F5. So here you can see an error message is shown. Matrix dimensions must agree, because otherwise minus operation cannot be performed. So if I remove the fourth row from here also, now the subtraction operation can be performed. Now you can see the output is shown over here. Now about matrix multiplication. So for that, simply write a star over here, multiplication sign to be added. Now press F5. So this is a matrix multiplication. So this is matrix A, then matrix B is there, then matrix C is equal to product of the matrix A and B. This is an actual matrix multiplication. On the other hand, if you just want to multiply element by element, so for that you need to add one extra dot over here. Now press F5. So here you can see this multiplication is different. Dot star multiplication is element by element multiplication. So what happens over here? First element, first row, first column is taken from A, then first element over here, first row, first column is taken from B. These two are multiplied together, so their product will be 10, and that is stored at first row, first column of C. Similarly, all other elements like third row, third column for A is 9, third row, third column for B is 90. So 9 into 90, that is 810, right? So that value is stored in at location third row, third column of matrix C. So this is a element by element multiplication, and this is different from matrix multiplication. Okay, suppose I want to find the determinant of a matrix. So how to do that? Type det bracket, round bracket, then here I write a. Now let's press F5. So determinant of a is 0. Suppose if I write over here b, now press F5, determinant of b is also 0. Right? So let me change the value over here. Let us change one value. See, instead of 60 I write 600. Now see the effect. Press F5. So see, determinant of b has got some value over here, 3,24,000. Now if you want to find out inverse of a matrix, so for that I write inv and press F5. So this is the inverse of b. This c is equal to inverse of b. Now if this is inverse of b, then let me define another matrix B. So if C is inverse of B, then B into C must be an identity matrix. Let us check that. Now press F5 over here. So here you can see D is an identity matrix. The elements over here along the diagonal are 1 unity. Rest of the elements are 0. Right? So this is an identity matrix. Similarly, even if I write another matrix E equal to C into B, that should also be an identity matrix. So let us check that also. So here you can see this E is also an identity matrix. All the diagonal elements are 1 and rest of the elements are of diagonal terms are 0. Suppose I want to divide one matrix by the other, right? So I write A divided by b. Let us see the effect. So this is a divided by b, right? And if I write another matrix e equal to c into b, now press F5. So what should it be? That should be actually same as a, because if I further expand this formula, this becomes a by b into b. So that is equal to a. So let us check whether it is equal to a. So a is 1, 2, 3, 4, 5, 6, 7, 8, 9. So d is also 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us check with some other values also. Let me add a 0 over here, 1 0 over here, 1 0 over here. Now press F5. So again D is 123, 4, 5, 60, 7, 89. So that is exactly same as mentioned in the input. Okay, this was about matrix division. Now if you want to divide element by element, so let us see how to do that. Now press F5. So here you can see element by element division is there. So how is it done? Here you can see first row, first column element is 1. For B, the first row, first column element is 10. So 1 divided by 10, that will be 0.1, and that is placed over here, first row, first column of C, the output matrix. And let us check it for the last element, third row, third column. For A is 9 divided by third row, third column of B element, that is 90. So 9 by 90, that is 1 by 10, right? So that will be 0.1, and that is being shown over here. Third row, third column element of C, 0.1, which is 9 by 9 by 90. So that is 0.1. Again, this is not a this one is not a matrix division. This is only element by element division. Okay, we have discussed it till now two-dimensional matrices only, and there is an important observation which must be discussed over here. Suppose this B is not a square matrix, so I add few more terms over here. Now it is not a square matrix. Now in this case it will not be possible to find out its inverse B. So here you can see matrix must be, it is giving an error, matrix must be square, right? So this inv command cannot be applied to a matrix which is not a square matrix. So till now the matrices which we have discussed are two-dimensional matrices. Now we will see how to define a 3D matrix, and later on we will see how to define n-dimensional matrices also. Here you can see this is an example of a 3D matrix. Actually in 2D matrix we talk about, let's say for a 2D matrix we say that first row first column element is over here. The matrix index we talk about only two indices, right? Second row first column, and then there is third row first column, and then there is fourth row first column, and so on, right? And for second column we say that this is first row second column, then second row second column, third row second column, and fourth row second column. And then we go on first row third column, then second row third column, then there is third row third column, right? And we say there is another element fourth row third column. Then similarly these are the elements related to fourth column, right? And rest of the terms, indices you can see over here, rest of the indices are, this is 1, over here also this is 1, this is 1. So this is, you can say, first slide kind of thing. You can call it as a first slide, or you can call it as a first page, or you can call it as a first layer, or you can call it as a first OHP slide, overhead projector type slide, right? And then for second page or for second layer, you have similar kind of arrangement, first row second column, first row first column, right? Similar kind of arrangement is there, but rest of the elements, the third index is 2 over here, right? So over here you can see all the elements, their third index is 2. So for all the elements the third index is 2 over here. Then for third layer the third index is 3 for all the elements, right? So this is how a three-dimensional element formation, matrix formation is done. Here in this diagram the element indices are shown. This is not an actual 3D matrix. Element indices are being discussed over here, right? Okay, how to create a 3D matrix, that we will discuss in our next class.